Hi everyone, this is the 9th video of the ACT Math practice problem series, and here we have a nice little exponential equation. And as I always say, before seeing the solution, pause the video, try to solve it yourself, and then you can of course match with my solution. Alright, so let's get started. So here we have an exponential equation, so we have a left hand side and a right hand side, and this can be solved in couple different ways. First I'm going to try the simplest way. Let's try to solve the left hand side first. So let's try to come up with a simplified version of our left hand side. So you can say LHS is equal to a to the power b over a to the power c, and from here can we say okay, this must be a to the power b minus c, and this is using the property of exponent which says a to the power m over a to the power n is equal to a to the power m minus n. I'm using that property. So using that property, here we can say a to the power b over a to the power c is actually equal to a to the power b minus c, right? And similarly, what is our right hand side? Well, our right hand side is like this. It has 1 over square root of a. So can we write it as 1 over a to the power 1 half, because square root gives us an exponent of 1 half, so we can write it like that. And because it is in a reciprocal form, can we write it like this? So we can say okay, whatever is the power, it will become a negative power, so it will become a to the power negative 1 half. And what property did we use for this one? Well, this is the property that we just used. It says that if you have 1 over a to the power m, it is same as a to the power negative m. So if you take the reciprocal, then the exponent will become negative, just the sign will change. Positive will become negative and negative will become positive, right? So here, because we had a to the power positive 1 half, now I am taking the reciprocal of it, it will become negative 1 half exponent. So then now if you compare both the left hand side and right hand side, it kind of looks like this now. A to the power b minus c must be equal to a to the power negative 1 half. And now you see that we have the same base on both sides. So now we are going to use the concept of exponential equation, and from there we can say okay, then definitely b minus c, the exponent on the left hand side and exponent on the right hand side, they must be equal. So from here we can say okay, then b minus c is equal to negative 1 half. And now if we multiply both sides by 2, then we are going to get 2 times b minus c is equal to negative 1. And then if we bring the negative 1 to the left hand side, this will become 2 times b minus c plus 1 is equal to 0. And if you look at our answer options, we already see the answer there, which is the option E. 2 times b minus c plus 1 is equal to 0. We could have solved it another way also, so let's give that a try. So the other way would be like this. We had a to the power b over a to the power c is equal to 1 over square root of a. From here, can we write it like this? We can say okay, then a to the power b minus c is equal to 1 over square root of a. And then from here we can say okay, then a to the power b minus c times square root of a. So I'm just doing a cross multiplication. I'm bringing the square root of a to the left hand side. Then on the right hand side we are going to be left with 1. And from here also we can say that a to the power b minus c times a to the power 1 half, because square root gives an exponent of 1 half, is equal to 1. And from here what do we get? Well, then we can say a to the power b minus c plus 1 half. All of that is equal to 1. And can we write this 1 as a to the power 0, because any non-zero real number with a power 0 gives us 1. Now you see it is looking like an exponential equation because we have the same base on both sides. So now we are going to equate the exponents. So then from here we can say okay, then b minus c plus 1 half must be equal to 0. And now if we multiply both sides by 2, we are going to get 2 times b minus 2 times c plus 1 is equal to 0. And from there we can clearly see that if we take 2 as a common factor, then we have b minus c. So 2 times b minus c, then plus 1 is equal to 0. And that also matches with our answer option E. So you can solve it two different ways. Whichever way is easier for you, try to do it, because time is very important in the ACT math exam. So whichever way you feel more comfortable, try to solve it that way. I hope everything made sense. Thank you for watching. See you in the next video.